Okay, so this is just a recap from yesterday. Take out those little sheets that you got. All right, you're going to need those for today. Everybody have their little sheets? Because you're going to add some stuff to the back of it today, okay? All right, so just remember our hypothesis is what? P or Q? P. Very good. What is Q then? What's it called? Ooh. The answer the C. Yes. Conclusion. Very good. Okay. So keep those in mind. These little squigglies right here means you're adding the word not, which is another way of saying negate. Negate means to add the word not. Okay. So keep this out as we go through this. Now, let's take a look at example 4. This is saying write and determine the truth value of the inverse and contrapositive of the conditional. If two whole numbers are both even, then their sum is even. So the hypothesis was in this case, two whole numbers are both even, and the conclusion was that the sum of the two whole numbers was even. Now we learned about converse yesterday. We would just take these two and we would flip it. Okay? But for an inverse and contrapositive, we need to negate it. So that means we're adding the word not. So it says two whole numbers are not both even, and the sum of two whole numbers is not even. So in this case, we're going to have the inverse, which is not the hypothesis, and then not the conclusion, giving us if two whole numbers are not both even, then their sum is not even. And then for the contrapositive, we take the inverse and we flip it. If the sum of two whole numbers is not even, then the numbers are both not even. Now, if we look at this, we can see that if two whole numbers are both even, then their sum is even. That's true. If two whole numbers are not both even, then their sum is not even. That's kind of false right there. Okay. So here is our truth table. It says, let's take a look at the truth values. Conditional would be true. Our converse, if we flip this, would be false. Our inverse would be false. And then our contrapositive would be true. Okay. What are you guys noticing here with this pattern? What matches? Well, the conditional and contrapositive match, and so does the converse and the inverse. Okay, so that's something you need to keep in mind. All right, let's take a look. I want you guys to try this. Write and evaluate the truth table of an inverse and contrapositive. So it says write the converse, the inverse, and the contrapositive. What is the truth value of each? I believe you're on page 21 of the book. So write the converse, inverse, contrapositive, and tell me if they are true or false. Go ahead. I'm just double checking. I don't see Lucy, Anandi, Isabella, or Sarhan. No, Sarhan in there. Wait, no, she's gone. Okay, so anybody okay, just double checking. So I think we're good. Okay, so I'm missing 4 today. All right, who's still working on these 3? I'm going to give you the answers because I know we're kind of getting our feet wet with them. Anybody still working on them? All right, so let's take a look at the first one. So the converse should be, if tomorrow is Monday, then today is a weekend day. True or false? True, definitely. All right. Questions on the converse that I can address? All right, inverse. If today is not a weekend day, then tomorrow is not Monday. True or false? Yeah, definitely true. Any questions on the inverse? All right. Contrapositive. Tomorrow is not Monday, then today is not a weekend day. True or false? Definitely false. What's the counter example for that? Go ahead. Saturday, right? All right, questions on that? All right, let's take a look at this one. So it says, again, let's take a look at this from this example. So it says the conditional was false, the converse was true, the inverse was true, and the contrapositive was false. So here is the pattern that you're going to want to write down on the back of those sheets. The equivalent truth values are always, the conditional and the contrapositive will always be the same, and the converse and the inverse will always be the same. Okay? So if one's false, then the other's false. If one's true, the other's true. Questions on this? Okay. Anybody still writing? All right. The biconditional statements. A biconditional is the combination of a conditional P to Q that is, and its converse Q to P. The resulting compound statement is P such that Q. They're kind of like, they're reliant on each other. Okay. And it goes if P, if and only if Q. This is something you need to write down on the back of that sheet. The conditional and the converse must be true in order to write a biconditional statement. I know it says put it on their hand if it's a mine, but now we have these half quarter sheets, so write it on the back of that. If the conditional and the converse are not true, then you do not have a biconditional, okay? Anybody still writing? All right. So example 5, a marine biologist writes this conditional. If a seahorse gives birth, then it is a male. Since it is true that among seahorses only males can become pregnant and give birth, should the marine biologist state this as a biconditional in a paper she is writing? All right, so again, we're going to take a look at that hypothesis. In this case, the hypothesis: a seahorse gives birth. The conclusion: the seahorse is male. Now, if we look at this, we have to look at each individual part. So if we look at the conditional, if a seahorse gives birth that is male, that is true. However, if you take the inverse of this, not the inverse, I'm sorry, the converse of this, if a seahorse is male, then it gives birth, that's false. Because these both are not true, you do not have a biconditional statement to work with. Okay? Questions on that? All right, let's take a look at number 5. So it says, write the converse of the conditional statement below. Write a biconditional for the following conditional. What is the truth value for the conditional, converse, and biconditional? So here we have, if two lines intersect at right angles, then they are perpendicular. Is this going to be true or false? What do you guys think? Hands for true? Yeah, I'd say true too. So we're still in the game to have that biconditional because it's true. And what I want you guys to do is write down the converse, check if it's true. If it is true, then write down the biconditional. Go ahead, give it a shot. All right, show of hands who is still working on these two. Okay, give me another minute. Okay, let's check out the converse. Who would like to give me the converse? Go ahead. Very good. Would this be true or false? Very good. Two lines perpendicular, then they intersect at right angle. So there's our converse. So now we have a true conditional and we have a true converse, which means we do have a biconditional statement. Who would like to tell me that one? Ooh, not all at once now. Can't handle it. So many hands going up. Go ahead.
If and only if two lines intersect at right angles, they be perpendicular?
Okay, so we got two lines intersect at right angles if and only if they are perpendicular. And that ends up being true as well. Are there any questions on this? Okay, so example 6, we're going to flip-flop the process, which means they're going to give you a biconditional, and then they want you to find the conditional and the converse from that biconditional, okay? Safe to move on? Okay. So example 6, what are the two conditionals associated with the biconditional? A triangle is equilateral if and only if it has 3 congruent sides. Identify the two statements in the biconditional. A triangle is equilateral would be the hypothesis. The conclusion would be a triangle has 3 congruent sides. So you identify the hypothesis and the conclusion within this biconditional, okay, which means usually this and then that. And then you write the two conditionals. So the conditional would be if a triangle is equilateral, then it has 3 congruent sides. And the converse would be if a triangle has 3 congruent sides, then it is equilateral. Here's your study tip though. Remember that because the conditionals that form a true biconditional are also true, you can choose either part of the biconditional as the hypothesis and the other part as the conclusion. Okay, so that's going to be dependent on you. Questions on what we're finding and what we're doing with this, or in general? Okie dokie. Try number 6. So what are the two conditionals associated with this biconditional? The product of two numbers is negative if and only if the numbers have opposite signs. Go ahead and write down the conditional and converse. You're done. You're out of time. What do you got? Well, you gotta read where the midpoint is. Okay, so what does that tell you? Perfect. Good idea. That I can't tell you. It sounds like the setup was correct though. You got like 5 more minutes. That's it. Okay. All right. Who's got the conditional? Go ahead.
If the product of two numbers is negative, then the numbers have opposite signs.
Perfect. If the product of two numbers is negative, then the numbers have opposite signs. How about the converse? Go ahead.
If numbers have opposite signs, then the product is negative.
Perfect. If two numbers have opposite sides, then their product is negative. Any questions so far? All right. I want you guys to work on these, 5? Okay. From the do you know how? Okay. Okay, show of hands who's still working on these problems. If you are, okay, maybe more time. All right, show of hands. Who's still working on these? All right. Okay. Let's go over them real quick. So number 6, write the following statement as a biconditional. A prime number has only one in itself as factors. Someone tell me what's the biconditional gonna be? Go ahead.
If and only if a number is prime, it has only one in itself as factors.
Okay. Anybody got something else? I would put the if and only if in the middle. Okay, but outside of that, it sounded good. Number 7. Okay, it says if a rectangle has an area of 12 meters squared, then it has side lengths of 3 meters and 4 meters. What is the hypothesis? What is the conclusion? Number 7. Who's got it? Go ahead. Okay, so hypothesis, rectangle has an area of 12 meters squared. Conclusion? Perfect. And then side lengths of 3 and 4 meters. All right. What is the truth value of the conditional? True or false? We've seen rectangles. 3 and 4 is true, but what's overall it's going to be?
That's gonna be false because it could also be 6 and 12 or 6 and 2.
It can be 6 and 2. It can be 1 and 12, right? We have counterexamples, so it's false. What are the converse, the inverse, and the contrapositive? What are their truth values? All right, so in this case, the converse is definitely going to be if a rectangle has side lengths of 3 and 4 meters, then it has an area of 12 meters squared. Would that be true or false? Yeah, that would work. The inverse negates. So if a rectangle does not have an area of 12 meters squared, then it does not have the side lengths of 3 meters and 4 meters. True or false? Contrapositive switches the negation. If a rectangle does not have the side lengths of 3 and 4 meters, then the rectangle does not have an area of 12 meters squared. And then what 2 conditionals are associated with the following biconditional? The city can build new roads if and only if the if sales tax is raised to 8%. So the 2 conditionals would be if the city can build new roads, then the sales tax is raised to 8%. And the converse would be if the sales tax is raised to 8%, then the city can build new roads. Okay? Questions? Anything? All right, that's it. Those of you watching at home, have a great day.